Dynamic programming is the art of designing an algorithm to solve some problem that has overlapping, optimal substructure. This means that you can break the original problem down into relatively few unique subproblems, and then when you solve those subproblems, you have solved the whole problem. There are no lack of books on the subject. Here's one by Professor Richard Bellman himself, the inventor of the technique way back in the 1950s. And here's one for people who like to plan ahead. A search of Google will reveal zillions of resources. So it certainly seems like this is something students struggle with, but they still need to learn. As part of the research for this project, I found an article by Michal Forishek called Towards a Better Way to Teach Dynamic Programming. In it, he outlines 8 lesson plans to teach the subject in a systematic way. I decided to implement these lessons as Jupyter notebooks because that way I could integrate video, coding, quizzes, and other interactive elements. The course portal, so to speak, is here, this GitHub repo. My intended audience is computer science students preparing for a course like graduate algorithms. You can think of it like a workshop, something to complete on a weekend, for example. The intention is to give students a very strong foundation, a way to think about dynamic programming problems that will make the real algorithm course they take later a little bit easier. So they, or maybe it's you would come to this repo. There's some stuff here, some explanations on how to run the notebooks. So to get into the notebooks, you click on this link, and Binder builds a Docker image, and then you wait. You wait a bit for the notebook to open. The advantage of binderizing the notebooks is that the student doesn't need to set up an environment or install anything. The disadvantage is that the environment is only semi-permanent. It only stays open as long as the browser is not idle. So it could be worthwhile for a student who wants to save their work to install the Jupyter environment. One reason I'm using Jupyter Lab instead of plain old Jupyter notebooks is because I like the way you see all the lessons in this panel on the left. When you're in a notebook, you can see the outline, a table of contents, by clicking over here. The quizzes don't usually show up without the notebook being run. This is one of the things I'm trying to improve. In any case, you just run all the cells and everything shows up as it should. So the part I really like are the quizzes. I coded the infrastructure myself because I couldn't find anything ready-made that did exactly what I wanted. The reason the quizzes were so important to me is that I use them to explain things instead of writing those explanations in text. I think it's more engaging that way, and it's also educational because it gets the student to figure things out by themselves. For example, I tried this palindrome quiz on my husband, who's a humanities guy, and of course he missed the single letter and the empty string. But by getting it wrong, it opened his eyes to the concept of empty strings, and he learned about proof of trivial case, and he sort of felt like he learned it on his own. So each notebook has a video to introduce the subject, usually a diagram or two, quizzes, and coding exercises. The main advantage of the Jupyter Notebook is that the student can code up the algorithm directly in the notebook and then run it. There's even some light profiling using magic commands, and I hid the solutions at the bottom of each notebook. The course is still in active development. I can add more content, more videos, more practice problems. I already got a lot of encouraging feedback, but as they say, the proof is in the pudding. So go ahead and try it out.